Hello friends, and welcome. Here is a question. Imagine you want to tell a friend where you live. You do not pick up your house and hand it to them. You just give them the address. Your friend now knows exactly where to go. That is the core idea behind a pointer in programming. A pointer does not hold a value directly. It holds the address of where that value lives in memory. Simple as that. And once you have that address, you can navigate. You can move from one location to the next, which is exactly what Traversal is all about. In this video, we are going to build that idea from the ground up, step by step. Let's start with how variables actually live in memory. Alright, so we said a pointer holds an address. Let's make that concrete. When you declare a variable, your computer reserves a slot in memory for it, and that slot has a location, called an address. Think of it like a numbered box in a warehouse. Here, we declare an integer x equals 42. Somewhere in memory, the value 42 sits at a specific address, say 0 by 108. Now, int star p equals ampersand x. The ampersand is the address of operator. It grabs the address where x lives and stores that address inside p, so p does not hold 42. It holds the location of 42. That distinction is everything. P is just a variable like any other, except its value happens to be a memory address. In the next slide, we will see how to follow that address and actually read what is stored there. Now let's look at dereferencing, using a fresh example that keeps the same idea we just built. Here we have an integer called score set to 42, and a pointer called ptr holding score's address. Different names, same pattern as before. But how do we actually get to the value sitting at that address? That is where dereferencing comes in. Think of the pointer as a label on an envelope. Dereferencing means opening the envelope and reading what is inside. In code, you put an asterisk in front of the pointer, so star ptr. That tells the program, go to the address stored in ptr, then read the value there. Since ptr holds the address of score, and score equals 42, star ptr gives us 42. Step by step, ptr contains 0x200a. The program goes to that address. It finds 42 sitting there. That value is what gets assigned to val. One address, one read, one value. And that simplicity is what makes pointers so powerful, as we will see next. Alright, so why do pointers exist in the first place? Here is the core problem they solve. When you pass a variable into a function, the program normally makes a full copy of that value. For a single integer, that is fine. But imagine passing a large block of data, a structure with dozens of fields, or an entire array. Copying all of that every time is slow and wastes memory. A pointer sidesteps that entirely. Instead of copying the data, you hand the function a small address, just enough to locate the original. The function works directly on what is already in memory. No copy made, no extra space used. That is the efficiency argument. But there is a second benefit: indirect access. A pointer can reach into memory and modify the original value, not a local duplicate. Next, we will put this to work by walking a pointer through an array, one element at a time. Alright, now let us walk a pointer through an actual array step by step. We have 5 integers stored at addresses: hexadecimal 100, hexadecimal 104, 0 by 108, hexadecimal 10c, and 0 by 110. Each 4 bytes apart because an integer is 4 bytes wide. Our pointer, ptr, starts at 0 by 100, pointing at the first element, which holds the value 10. When we write ptr++, the pointer does not simply add 1 to the address. It adds 1 times the size of the type, so 4 bytes, landing at 0 by 104, which holds 20. Increment again, and it reaches 0 by 108, giving us 30. Each step moves exactly 1 element forward. That is pointer arithmetic. Dereferencing ptr at each position reads the value sitting there. No index variable needed. The pointer walks the memory directly. In the final slide, we will pull everything together into one clean mental model you can carry forward. Alright, let's bring it all together. A pointer holds a memory address, nothing more. When you dereference it, you reach through that address and read the value sitting there. When you write ptr++, it steps forward by exactly the size of the type it points to, landing cleanly on the next element. That is the traversal pattern we walked through on the last slide. Ptr starts at 0 by 100, reads 10, moves to 0 by 104, reads 20, and so on, all the way to the end. No index variable needed. Here is the one mental model to carry away. A pointer is just an address, dereference to read, increment to move. Master that, and arrays, linked lists, and most of systems programming start to make real sense. Thanks for watching, friends. See you in the next one.